Good afternoon, everyone. I think there are still many more people to join in. So let's give a few minutes for them to join in, and then Barney would also join us, and then we can get started today. Good afternoon, everyone. Can you please confirm if you can hear me? All right. So for those of you who have just joined us or who have not watched the previous sessions, I am sharing the link to our recordings. So please go through it and you can watch all the previous sessions. All right. And I remember some of you were asking for LinkedIn because you said you don't use Facebook and etc. So for those of you, we have LinkedIn as well. So I am sharing the URL in the chat. So give me one more second. Yeah. All right. Day one session, guys, we are still in the conversation. So don't worry. Worst case, if it has to be, then we will just record a session and put it. Don't worry about it. You will get the day one video. Don't have anything to worry. All right. So for those of you who are not on Facebook and who couldn't join us on Facebook yesterday, you could just, I've shared the link. Just click on that link and click on follow, and there you can follow us. So all you need to do is just click on follow, and you'll be notified, you'll be updated about all the different programs that we are doing. So for example, you could see some short snippets that we have created especially for you guys. So please make sure that you follow us on LinkedIn as well, and just give me a confirmation once you have done so.
Hey Enoch, I've joined.
Awesome, Barney. All right, I just shared, just to fill you in, I've shared them the LinkedIn URL for those of, for all of them who prefer LinkedIn.
Okay.
So they can stay in contact with us through LinkedIn.
Sure. Wonderful.
Yeah. Over to you, Barney.
Yeah. Thank you, Enoch. So let me first do this. Today, completely, we will be spending on image processing, and we'll look into a lot of stuff. Let me open the screen and then I'll share with you. Just a moment. I'm trying to open Anaconda. It's open. Let me open now Spider. Got it. So let me also open the computer vision image processing stuff. Yep. Let me share the screen in a minute. Okay. Yep. So my name is Bharani Kumar, and today and tomorrow is the last day. Okay, so it's been what? This is the 5th day of the session, right? Yeah, this is the 5th day of the session. And I see that a few of y'all are extremely energetic. And by the end of the session, I think it will be around 200, 250 people are joining. That's the trend that we have observed. Could be that they want to just get attendance, or could be they want certificates, so they are just logging in at the last moment. Nevertheless, and a few of you all, I'm sure, want knowledge, so that's the reason why you have joined in. Wonderful. So here is a question. If I give you a camera and a still scene, And if I say reduce the noise, how would you do that? Simple. You have to take a lot of images, and for each of the image, choose the pixel value. If this is the first pixel value, which color do I choose? This one maybe. Choose pixel value. This is say pixel 1. You choose the pixels and then take an average of those pixels. Then go to the second pixel and then take an average of all that. Then take the third pixel and take average of all those pixels. Then take the fourth pixel and take average of all of that. That's what we need to do. How do we do noise reduction when you have a one-dimensional signal? Audio files and speech transcripts. Audio files and speech transcripts are one-dimensional in nature. Okay, they are one-dimensional in nature. And so if you look at these, somewhere there's a spike. That means there will be, this is an error basically. And you see a lot of ups and downs in the signal, original signal. There's a lot of noise. That is what it means. How do you reduce the noise? To reduce the noise, you can just do something called as moving average. You can do something called as moving average. What is moving average? So say you want to find out the new value for this. Then what you do is, if you choose a window basically, you can say I want a moving average of 5. What does that mean? Including this middle pixel, you take 2 pixels on the left and you take 2 pixels on the right, and then you take average of all those numbers. That's going to be your number here. On similar lines, if you want say a smoothened version, or this signal has say noise, you want another signal which does not have noise, or say you want to reduce the noise. How do you reduce the noise? Including this pixel, you take 2 pixels on the left and 2 pixels on the right. So if you have 5 pixels, and if you take average of those 5 pixels, you get this. By applying a simple moving average, you actually reduce the noise of a signal. Right? Going by the same logic, if I apply this principle or concept to an image, what would happen? Let's see. If this f of xy, if this is your input image, and if this is your output image, then you can decide on what should your moving average be. When it came to your signal, it was a one-dimensional thing. But here it's two-dimensional, because you'll have image would look like this, right? Image. And image will have x and a y. Image will have x and a y. Okay, so you need two dimensions. Unlike your signals, which are one-dimensional, images are two-dimensional. So you need to apply a two-dimensional moving average. So if you take a filter, this is a filter, a moving average filter, and say you're taking a 3 by 3 filter, 3 rows and 3 columns, right? 3 columns and 3 rows. 3 by 3 means it looks like this, 3 by 3. You take this and apply on this portion of the image, right? And when you apply on this portion of the image, you just take average of all these numbers, 0, 0, 0, 0, 0. If you have all zeros and if you take an average, you get 0. And that's the central pixel. That's the central pixel, and you have here. Okay. I mean, you're just making use of the bordering pixels and then taking an average of all of that so as to reduce the noise, and you get this. Then, if you move that, if you move this by one stride, they call it as one stride. Meaning, if you just move it by one stride, one pixel, it's called as one stride. And then you take average of all these numbers, all the numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9. Add all these numbers, you get 90 because rest all are zeros. Divided by 9, 90 by 9 will give you 10. And that's this number going to be 10. Then you again move it by one stride. Again, move it by one stride basically. When you keep moving it by one stride, this time say you moved it by another one stride. Move by one stride means you move by one pixel in that way. Then what you do is you take all the numbers which are here and then take average of all these numbers. That would give you the value for the central pixel. That will give value to the central pixel. Then keep moving in that way. Keep moving. Keep moving. Keep moving in that way. Okay, and then keep taking the average of those values and you get it. Very simple, right? That's moving average, and this is how you reduce the noise in your image. Now, there is also another thing which you need to understand, which is called as filter. Filter, which you apply on an image. Say this is your image, input image, and you have all the pixel values of your image. Then say you're taking a kernel or a filter or a mask. Say you've taken that. You have all these values. And say you're applying this kernel on this particular image. And then you're getting 8. How are you getting 8 is my question. Yep. Can someone answer? How do you think are you getting 8 here? How come we get 8 there? Yep. Let me see who can answer this. Any answer to that? How did you get 8 here? When you applied this kernel, how did you get 8? Let me see. Yes, exactly. So 0 into 10 or 10 into 0 plus 5 into 0 plus 3 into 0 plus 4 into 0, 6 into this plus 1 into this plus 1 into this plus 1 into this plus 8 into this. When you multiply all of those, it's a simple dot product. And when you add, you get 8. Everything is 0. So even if you multiply these zeros with these, you'll get 0. 6 is getting multiplied by 0.3, 0.5, so you get 3 plus 1 is getting multiplied by 1, you get 1 plus 8 is getting multiplied by 0.5, so you get 4. So when you add all of these, you get 8. There's a slight mistake here. It should have been like this. Sorry. Now tell me one thing. What should be the values within this filter? So this is like your input image. This is your filter. When you apply filter on your image, you get an output image. Okay, you get an output image. What numbers should I get here inside? What numbers should be there such that this number is 30? That means the central pixel that you're seeing, right, is 30. Yeah, please answer this. Take 2 minutes time, 3 minutes time. That's okay. And then can you please answer? Please, can you all answer? Why not dividing by 9? Why not dividing by 9 means? Manji, I'm explaining about various filters. That's it. Okay. So here, what values should come in such that you get 30? Do you know what? It'll be all ones. And let me tell you a couple of things here. Very important. 1 into 0 plus 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 1 into 90 will give you 90 plus 1 into 90 will give you another 90 plus 1 into 90 will give you another 90. So if you add them up, you get 270 divided by 9, which will give you 30. Why am I dividing it by 9? Because when you add all these numbers, when you add all these numbers, and when you divide all these numbers by 9, when you add all these numbers, you get 9. And when you divide it by 9, you get 1. That is what is mentioned here. If it's not mentioned, then the summation of all the numbers within your filter should be equivalent to 1. Okay, let me write it here. Or let me say why we are dividing it by 9, right? Summation of all numbers should be equivalent to 1. Okay, and then if you apply such filter on real world image, say this is your input image or the original image, say you take some filter, okay, and you put all 1 1 1 1 1 1 1 1 1 and divide by 9, right? Then what happens is you get an image, output image, which looks like this, filtered image. Okay, so I'm not sure whether you're able to observe that or not. There'll be slight boxy kind of appearance. You'll have boxes in that way. You'll have boxes, boxy kind of appearance. If you increase the filter size, say filter size, if you increase it by, instead of having 3 by 3, if I have a filter which is 5 by 5, then what do you think will happen to the output image? Will the amount of blur, it became blurry if you observe. There's a lot of blur. Will the amount of blur increase or decrease? If I increase the filter size, what will happen to the amount of blur? Let me ask a poll question. Okay, Manjil has this question. Manjil, if you're able to hear me, okay, I'm just explaining you something called as linear filtering here. Okay, I'm explaining how a filter works. Right from word go, I will not say I will divide it by 9, I'll divide it by 100 or 200. I'm not saying that. Just to explain you a small concept on how kernel operates, I just took an example, Manjil. I just took an example. There's nothing alarming about it. Then what I'm doing is I'm adding more information to it. See, I need to take you from LKG to UKG to first to 10th standard, right? Right from the word go here, if I introduce you 10th standard concepts, you might not understand. That's the reason why I just introduced the concept of kernel here, and then you are clear with this LKG concept. Now I'm taking you to upper kindergarten, wherein I'm saying, okay, when you have all the numbers within the kernel, when you add all these numbers, if you're getting 9, you divide it by 9 so that summation of all these weights inside the filter is equal to 1. I am slowly introducing you UKG concepts now. Now I'm taking you to first standard and explaining you another filter. Am I making sense? Am I making sense, Manjil? Am I audible in the first place? Okay. So let me ask you a question. If the filter size increases to 5 by 5 from 3 by 3, then will the amount of blur increase or decrease? Let me see who is going to get the right answer. Yep. Can you answer this? Wonderful. Exactly. The amount of blur will increase. Why? Because if you say you're using a 3 by 3 filter, you apply on this portion. Okay, you apply on this portion. And then you take, you multiply the values with your filter and get the new value out. And you'll get the new value out. But then, if you take a 5 by 5 filter, when you take a 5 by 5 filter, and then if you apply on this 5 by 5 patch, you get this middle value. You get this middle value, right? So you're taking more pixels around the neighborhood of this central pixel. If you have 5 by 5, around the neighborhood of this central pixel, you're taking all these pixel values and then you're calculating. The more pixels that you move to, and if you take knowledge of all these neighboring pixels to come up with the central pixel here, then the amount of blur will be more. If you choose a smaller portion, yeah, blur will be less. If you choose a larger portion, blur will be more. Okay. Because of this boxiness, the boxiness that you're able to see, in this image, you have to carefully observe and then you'll find all those boxy stuff. To counter that, people have come up with something called as Gaussian filter. Gaussian filter. Gaussian is nothing but a normal distribution. It looks like this. Now I'll not get into the normal distribution and all that. It's out of scope. So normal distribution is also called as Gaussian distribution. And you have a filter. You have an image. This is an input image. We know that image can be represented as pixels. And then you have a filter. So here in this Gaussian, you have 4 at the central pixel, right? So that's at the peak here. Then you have immediate neighbors as 2. So immediate neighbors that are there are 2, 2, 2, 2, 2. Then the diagonally opposite are 1, which will be here. Why am I dividing it by 16? Yep, question to you. Why am I dividing it by 16? Please, can you answer? Why am I dividing it by 15? Or 16 rather. Yeah, please, can you all answer on why I am dividing this by 16? Come on. I request everyone to respond on this. Come on, friends. Absolutely, Srinivas. Absolutely, Srinivas. Not 4 by 4. Sum of all these numbers is 16, right? If you say 1 plus 2 plus 1 plus 2 plus 4 plus 6, or plus 2, sorry, plus 1 plus 2 plus 1. When you add all these numbers, you get 16. Okay, when you add all these numbers, you get 16. So it's 1 by 16 into all these numbers. 1 by 16 into all these numbers would give you 1. Remember, because you're getting 16, you're dividing it by 16. So 16 into 1 by 16 is 1. Summation of all of your filter values should be equal to 1. It should be equivalent to 1. All right. That's Gaussian filter. And when you apply a Gaussian filter, look at the difference. This is your input image. If you apply a box filter versus a Gaussian filter, look at the output. Here in the box filter, you're seeing the boxiness. Here in the Gaussian filter, the boxiness is gone. There is no boxiness here. It's a good filter now. Okay. If I increase, if your normal distribution is like this, then there'll be some amount of blur. But if I increase the variance, sigma is called as variance. Variance is so much. If I increase the variance, then the amount of blur on your image will be more. If I keep increasing, the amount of blur will keep on increasing, right? As and how you keep increasing your sigma variation, the amount of blur also will keep on increasing. Okay. If I apply this filter on this image, what will happen to the output? So I have a filter or a kernel or a mask. If I apply that on the input image, what do you think will be the output? Yep. Please, can you all answer? Please, can you answer? You'll have to answer, friends. I request you all to answer. What will happen to the image? No change. Wonderful. Same image. Wonderful, friends. I truly appreciate. Um, a lot of y'all are getting it right. A lot of y'all are getting it right. Exactly. So just imagine this. Imagine on what's happening here. If I apply this on this, it's a 3 by 3. I'm applying here 3 by 3, 3 by 3. 0 multiplied by this, 0 multiplied by this, 0 multiplied by this, 0 multiplied by this, and 1 multiplied by the central pixel. 1 multiplied by the central pixel will give you that central pixel there. And 0 multiplied by this, 0 multiplied by this, 0 multiplied by this, and 0 multiplied by this. So we are not having, we are not taking, these neighboring pixels are having no influence. These neighboring pixels are having no influence on the output. Only the central pixel here, since it's getting multiplied by 1, is having an influence on your central pixel. Simple. Right? The central pixel there, if you multiply it with 1, you have a central pixel. So wherever you multiply, you're just multiplying the central pixel. You're multiplying the central pixel with 1. So you get a value. Then you move it here. And then you get there. So on and so forth. So there won't be any change absolutely. Another question. If I apply this filter on this image, what will happen to the output image? Yep. Take out time, think, and answer. If I take this original image or input image, and if I apply this filter on this image, what would happen to the output? Did I give away the answer? Not sure. Okay. So not sure how many of you have actually seen that answer. My bad. Let me see. Okay. Blur. Absolutely, guys. Absolutely. You're right. What you're doing is, say you're applying that on this portion. You're taking 1 multiplied by this plus 1 multiplied. You're taking all those. And then you're taking an average of those. All the pixels, neighboring pixels. And if you take average of that, that would actually make your image blur. This. A few things I would be skipping. All right. Yeah. And another thing is, When you use combination of filters, say you take this and apply here, and then you take this and apply on this, and then you subtract those two outputs, you get a sharpening filter. So these are the various things that people do. For example, I have a question for you. If I select this eraser, okay, if I select this eraser, and if I apply this eraser on this part, and if I apply this eraser on this red part, like that, what filter values got applied? Tell me. What filter values got applied? Let's see. What do you think are the filter values which are getting applied when I take this eraser and say, do that, do that. If I do this, yeah. Which filter, what filter values got applied? Any thoughts? If it's a 3 by 3 filter, what do you think will be the values in this filter? Hmm, Lavanya got it right. Friends, when you take an image, if it's a grayscale image, the pixel intensity values range from 0 to 255. 0 means black. 255 means white. So if I select this eraser, do that, what's happening? 255 is getting applied because it's white. And then if I click on this, which is clear the screen, throughout your screen, whatever is the size of the screen, that size filter gets applied. So this is a simple, filter. Now another question. How many of y'all have know about Adobe Photoshop or Picasso? How many of y'all know about Adobe Photoshop, friends? How many of y'all are aware of this? Can you please reply? You're aware of that? Okay. In Adobe Photoshop, when you look at eraser, there are multiple options of eraser. You'll have small eraser, medium eraser, large eraser. Okay, you'll have a lot of erasers. Now, what do you think those erasers would do? If I apply a small eraser, only a small portion can be wiped away. But then, if I choose medium eraser, major portion will get erased, and larger portion will get erased. Okay, yeah, that's the use of filters. Okay, edges. I think I need to spend some time on edges because we'll be using these kind of filters, and we'll be doing some edge detection algorithms. Okay, we'll be doing it in OpenCV. Sorry, I was just having some water. And just give me a minute. Yeah, so sorry. Okay, here, do you have, are you getting an illusion that these are rotating, or are these stable? Yeah, are these rotating or stable? Let me ask this as a poll question. Are the circles rotating or constant? Yep, please answer this. Hmm. Please, can you answer that? What do you think? Is it rotating or is it constant? Please answer, everyone. Okay. It's called as snakes and Sacchart's illusion. Okay, you are confused. I'm getting a mixed response. Okay, anyways, that's fixed, guys. That's fixed. It is just giving you an illusion. This is reality is that they're not rotating. But then you're being given an illusion that it is rotating. You're just being given an illusion that it is rotating. All these are rotating. This is called as snakes and saccharts. Okay. And then why edges are important in an image, right? If you want to process the entire image, say you have an image which is of 256 by 256 pixels. 256 by 256 pixels. That's a very big, I mean, not big, I mean, it's fairly small, but then there'll be a lot of pixels in this 256 rows and then 256 columns. Too many values will be there, right? And then if you have a human face like that, then um, you have to, rather than processing each and every pixel, which is going to be time consuming and it will, consume a lot of effort, rather than that, can we not have only the edge pixels and determine what is there in the image? So friends, what is there in this image? What is there in this image? Please, can you answer? And what is there in this image? And what do you think is there in this image? Yeah, please respond. Let me see whether you're responding or not. Okay. I request everyone to respond, please. Wonderful. So y'all are saying that this could be image of a human or a man, maybe. This is image of a horse, and this is image of an airplane. Just by looking at the border pixels, that too not all the pixels, only a few, you are able to make out what is there in that particular image. Very easily you were able to make out. Just by looking at the border pixels, you could make out what's there in the image. And this is exactly what we are going to do. So the moment you identify edges in an image, it really consumes less effort to be able to analyze on what is there in the image. And what all causes edges? Let's understand that. If you look at this, if you look at this, if I draw a line like that, there is depth discontinuity. That means this portion here and this portion here, these two are far away. This is like a sky, which is far off, and this is a building. That means there is depth discontinuity. Whenever there is a depth discontinuity, you'll see an edge like that. Illumination discontinuity, meaning here it is bright, here it's like a shadow. So there is color discontinuity or illumination discontinuity, right? Then you have surface color appearance discontinuity. So this is looking in a specific way. And then if you look at this, it's different. So there is discontinuity, so there'll be an edge. Here it's called a surface normal discontinuity, meaning if you just go around like that, if you're viewing from here, you are able to see only this part. If you go at the back and stand, you'll be able to see another part, right? So wherever your view stops, wherever your view actually stops, that's the edge. Okay. Now I'll not walk through and then make a lot of mathematical statements. That's not the intention of the program. Okay, here to identify edges and to identify vertical edges, to identify vertical edge, you have these values such as 1 0 minus 1, 2 0 minus 2, 1 0 minus 1. When you have such values, when you apply such a filter on the image, when you apply such a filter on this image, then what happens? You will find vertical edges. When you have these values, you'll find vertical edges. And a famous scientist by name Sobel has come up with these values. He experimented with various numbers and he found that if the numbers are in that way, 0, 1, 0, minus 1, 2, 0, minus 2, and 1, 0, minus 1, it was actually helping identify the vertical edges. And what edges will this filter identify? Let me ask a poll question here quickly. Let me add a new poll question. What edges does this filter identify? Vertical or horizontal? What edges? I'll just pose this poll and then take you guys back here. Yep. What edges do you think this filter is going to identify? Vertical edges or horizontal edges? Oh, so sorry, I didn't publish. Is it? My bad. Yep. Now I published. Yep. Can you please answer that? Now let me look at the responses. Horizontal, absolutely, friends. Absolutely. Wonderful. Good response. So here, the direction in which your zeros lie would be the direction of edges. If the zeros lie in a horizontal direction, then the direction of edges will be along that. If it's vertical, then edges will be along vertical direction. Question to you. I mean, there are a lot of scientists who have worked with various different numbers, and then they figured out that each of those would capture a certain kind of edges. This would capture what kind of edges? Quickly, this filter that I've highlighted captures what edges? Vertical or horizontal? Please, can you reply quickly? Wonderful. This captures what? Vertical. Wherever you have zeros, it will capture that. And this captures horizontal. This captures again vertical, this captures the horizontal edges. Interesting. What do you think this Roberts filter will capture? What kind of edge does it capture? Okay, let me ask yet another poll question. Let me see whether you'll be able to answer this or not. What edge will Roberts filter capture? Is it horizontal or is it vertical? Yep. Please answer. Yeah. What edge do you think Roberts filter captures? Does it capture horizontal or vertical, or does it capture any other, filter or any other edge? Diagonal, exactly. Why are you saying diagonal? Because the direction of zeros is along that direction, along the diagonal. In whichever direction you have your diagonals, you'll identify the edges along that. Okay. Okay. Now, there are many such edge detection algorithms. Okay. So all that aside, I would now walk you guys through the program. Program, where are you? Okay. I need to, I think, look at OpenCV and then pull not the translation stuff. Fine. No, no, no. I'll look at only those things which are important for you. Yep. Here, I think filters came up here. One second. I'm just trying to get Gaussian filter. Then histogram equalizer is not needed. Okay, fine. I'll show you the various filters and how you can use those filters. Okay. For this, remember one thing, you need to load CV2. What does CV2 stand for? Computer vision. Computer vision aspects. And then here we go. Okay, we are also importing NumPy as NP. And then I'm reading a file, which is an airplane. And then if you say image.shape, :2, that means you want this 331, 375, and 3. But you want only these two, rows and columns. Right? So you have 331 rows, 375 columns. That is what you're trying to get by using this. Image.shape. When you say :2, it will take 0 and 1. Whatever is given here, it will exclude that. So excluding 2, you want 0 and 1. Why? Because you're saying if you start with a blank space there, that means you want to start from 0. That is what it means. So you have rows and columns. Okay, and then you're creating a filter here. You're saying numpy.array, and then you want all these numbers in the filter. So this will look like this. It's a 3 by 3 filter. You want 0, 0, 0 and 0, 1, 0, and then you want 0, 0, 0. That's the filter that you want. Okay. And then you're assigning that to an object called identity kernel. Then what you're doing is you're saying, I want all the ones, numpy np dot ones. How many ones do you need? You want 3 by 3. So here when you say 3 by 3, you want 3 by 3 matrix with all ones in that. And then you want to divide it by 9, because when you count all these numbers, you get a 9, and then you divide it by 9. Then here, you're taking 5 by 5. And you have all ones. Okay, you're going to have all ones. And then you count all these, and if you count all these numbers, you get 25. So you divide it by 25. Now, if you say apply that filter, which filter do you want to apply? Kernel identity. And then you want to apply this filter. Okay, let me not erase it. So kernel identity is 0, 0, 0, 0, 1, 0, 0, 0, 0. Then you have kernel 3 by 3, which is all ones. One, all ones. And then you also have kernel 5 by 5. All ones. Okay, you are applying these 3 filters on your image. And then you want to see what's gonna happen here. There is also an inbuilt function called blur. Let's see what happens. Okay, I'm going to run all of these and show you the image of a plane. Okay, here is the original image. Then you have an identity filter. When you look at your image and when you look at the identity filter, both should look alike when you apply this filter, identity filter. Then you have a 3 by 3 filter. The moment you apply a 3 by 3 filter, you should see that it is slightly blur. In comparison to the original image, it's slightly blur. And then if you look at your 5 by 5 filter, the blur will be even more. So you have some blur in 3 by 3. 5 by 5, you have more blur. So you have original image, identity filter, 3 by 3 and 5 by 5. Yeah, and this is the normal blur. That's the inbuilt function, which will do small blur basically, right? So in this way, you can take your image and create a lot of varieties of those image by doing a lot of blur. Okay, I think it's just over an hour that we have started. So let's take 10 minutes break and let us be back by 3:15. Okay, break time. Let's be back by 3:15. Let me Hello. Okay. What is the process of pro- what is portrait picture? Portrait? I mean, I didn't quite get you, Venkat. Venkat. It won't be filters won't be in rectangular shape, by the way. Then what is the difference between MATLAB and R? See, MATLAB is licensed version, R is open source. Beyond that, whatever MATLAB can do, R also can do. Whatever R can do, MATLAB also can do. But R is more preferred. Okay, R is more preferred. Are you all back? Can you please confirm? Not sure. Let me take a quick poll. So here is a quick poll. Are you all back? Yes or a no? All right. Yeah, please can you answer? Wonderful. For this question, there won't be a no actually. Okay. So we understood here. Okay, we clearly understood here that we can define filters. Identity kernel, 3 by 3, 5 by 5, you can define filters. And then you can proceed further. There are also a lot of filters. You just need to play around. You just need to play with the various filters, and then you can make something called as a motion blur. Not coming in. Why? Not sure. Okay, anyways, that aside, you can do edge enhancing and all that is fine. Embossing is fine. Yep. Here, if I use a specific image, which is this, the original image, and then if you apply Sobel filter on the horizontal direction, and when you apply on the vertical direction, let's understand what's happening here. Let me put the original image here. Okay, so here you have a Sobel on the vertical direction. Vertical would be in this way. Okay, this in this way, if you move, it's vertical, right? And if you move along this direction, it is horizontal. Horizontal and vertical. If you look at this original image, and if you move on the vertical direction like this, then here it is black, here it is gray, right? Here is where there is change in color. Wherever there is a change in color, you'll have an edge like that. But then throughout this line, there is no change. If there is no change, there won't be any edge. Okay, again, if you come here there is a color change from black to gray color. There is a change of color. Whenever there is a change of color, there'll be an edge like that. But then here throughout, if you see, there is no change in the color, hence there won't be any edge because this is vertical. But when you look at horizontal, okay, when you start looking at horizontal, if you move along this direction, along horizontal direction, from here to here, there is a change in color from black to gray. Whenever there is a change in color, you'll see an edge. You see an edge there, the white one patch. But then here along this, There is no change in color, hence there is no edge. Simple. Now when you look at this, from here to here, it's black. From black to this gray, there is an edge. There is an edge. But then along this, there is no change in color. Right? Because you are following horizontal. You are applying horizontal Sobel edge detector. What are these edges used for? These edges are used to build algorithms. We'll get there. We'll get there. We'll look into facial recognition algorithm and all that. At that point of time, I'll tell you. Then there is Laplacian filter, that's fine. Erosion, canny edge detector, all that is fine. Vignette and all that, fine. So now what I shall do is, I'm going to give you something interesting to understand. Okay. So just give me 1 minute. Just give me 1 minute because I need to enable the webcam here. I need to enable the webcam so that you all see me. Not just you all see me, but then we will do some kind of analytics on this. Okay, so let me just choose this. And let's see whether enable the webcam or not. Just give me a minute. Yeah. So I'm going to adjust the webcam I just connected. This GPU machine doesn't have an inbuilt camera, unfortunately. So let's see. Okay. Let me do one thing. Let me come closer and then switch on this. So what this function does is, if you're able to see this, import CV and then you have CV2 dot image capture of 1 or of 0 rather, right? Sometimes you might have multiple webcams. When you have multiple webcams, okay, when you have multiple webcams, then you can choose anyone that you want. But here it is 0, means default webcam, CV2 dot image capture. And then it says, and you're storing that in some object called cap. Is that cap opened? Means is your webcam open? If it cannot open, it will throw an error. If it can open, it will open that and it will start capturing the frame of your image. And then if this is the frame of the image, it will center itself along X and along Y direction. It will center here. Whatever image that you're having will be centered. And the name of this will be input and you'll be able to see all the frames of the image. Okay, until you press an escape key. So let me run this and then show you on how it works. No, come on. Okay, let's see once again. Why OpenCV 4.2 error accession and resize. Is this function gonna work? CV2 dot resize. What happened? Webcam is installed. Is it because my webcam is being used by Webinar Jam? Not sure. Let me try once again this part. I think it is because of this Webinar Jam that it's unable to detect. Otherwise, it should have shown. Let me try out. So I'm going to show you now how to identify the eye of a person, how to identify face of a person, etc. But then why d- doesn't it work? Not sure. Let me try again. Are you able to hear me? Are you all able to hear me? Yes or a no? Okay, can you please respond because I'm just testing out whether this webcam is working or not. Okay, perfect. So let me again connect this. I don't know why. Let me give a try. Yeah, now I think it should work. Yep. So that's me, people. And then I can also do a color space. If I press G, it will give in green, gray color. If I press Y, it will give my details in okay, YUV format. And if I press H, this is called as HSV format. Okay, these are the various formats in which you can display yourself. We'll do many things. Friends, a few of you all are asking for the code and the PPTs. Unfortunately, we will share it with our full-time participants only. But then recorded videos are anyways there. So you can watch those. Everything is there in that. Okay. Code, yeah, we might not be able to share because of certain issues. We do projects for various customers and some amount of code that I'm trying to show you is from there. So please don't ask me. Unfortunately, I will not be in a position to share. That's the problem. Okay. Please don't mind. Okay. Then there are a few fun-filled stuff that we are going to do now. What is it that we are going to do? We have frontal face detection algorithm. Okay. Within OpenCV, there is something called as Har cascade algorithm. This, by the way, I have to tell that only computer vision, I think, in our actual AI and deep learning training, which is for 80 hours, we train only, computer vision for 8 hours. We get into the depth of each and every algorithm and then a lot of additional things you do because it's 80 hours. That's the difference, Anyways, so I'm of course trying to ensure that I give you the, help you guys scratch the surface of these concepts so that you move further and study more. I mean, these trainings are good for you to give a good heads up, but does not mean you can master everything in these hours, right? That's why a lot of your questions, if I'm avoiding, that's the reason. Okay, because I need to explain many other things in order to clarify a few of your doubts. That is not possible in such a short time. It's not possible, right? So here, of course, you also, I believe, do not have programming background, so I'm doing this. So if you see that green bounding box, yeah, um, that's kind of frontal face recognition algorithm. And then you can also do, you can put a mask on your face. Let me do that. That's called as augmented reality. Augmented reality means putting an object on top of another object. That's augmented reality. Okay, so for this augmented reality, I can explain you on what we are trying to do. Let me go to our AI spray and then explain. AI spray is our learning management system. And what we do as part of this learning management system is we do a lot of artificial intelligence stuff. For example, okay, I'll explain. We have a speech recognition system. Say you're watching a video. Okay, say you're watching a video. If you're watching a video and say you have a doubt in one of the concepts, you have a doubt. What would you do? Basically, you just go to Google search or do something else, right? But what we will do is we are going to give you a chatbot functionality. There'll be a chatbot. In this chatbot, you ask questions and then you get responses. You keep asking questions and then you keep getting responses. If you have any question you ask, and immediately it will respond. So what we have done here is, um, I'm not sure whether I've spoken about this, but we take the video and we are going to break down this video into audio. We will extract audio from the video and then audio to text. We do audio to text and then do natural language processing using LSTM and bidirectional LSTM, etc. And we build this chatbot. So the moment you ask a question, it's going to respond back with an answer. And then we have behavioral analytics. What it does is it will also enable your webcam. When you're watching the video, it will ask you on whether you want to enable the webcam. If you enable the webcam, it's going to capture your features, behaviors, on whether you're sleepy, whether you're disengaged, whether you're on call while the video was being played, so on and so forth. And then it will give you a report which says that, hey, you have completed 2 hours of training, but then from 15th minute, okay, to 20th minute, you were disengaged. You weren't watching the video. You were doing something else. Do you want to watch these 5 minutes again? If you want to watch, click on this. The moment you click on this, you can watch that portion of the video. And finally, we are going to have the augmented reality. So if I'm the trainer, for example, my face, exactly my face would appear here. Okay, and you'll feel as if you're talking with me. You'll get a sense, you'll get an illusion as if you're talking exactly to me. And when you ask a question, this image is going to respond back to you. So you feel as if the tutor is always with you. You'll get that illusion that the tutor is always with you. That's the best part. Okay, that's augmented reality stuff. And then, yeah, AS Prime. I'll let you know, Venkatesh. We are trying to coordinate with the colleges and then get the count, and then we are putting certain conditions there. We'll let you know certainly. Sure, sure, Reno. We shall do that. Yeah, we have a lot of other plans, and then we will certainly push through. Okay, so here there is yet another program. What this does is it will put that augmented reality. Augmented reality means what if I can put a mask on my face? Can I do that? Look at that. That's kind of a mask. Okay. Mask. That's a mask. That part that you are able to see is actually the mask. Your mask detection algorithms, etc., that you're seeing are part of this. And then we also have eye recognition, meaning all your body components can be detected. All your body component, I mean facial components like eye, nose, mouth, everything can be captured. So, okay, and one more thing I need to actually talk about this because that's one of its kind that we are doing. So what we are doing is for a specific customer, since we are doing that automatic attendance tracking and we are doing this engagement, what's happening is if you have an image like that, you don't know what's there on the other side, right? It's masking. Like if you have a human face and say humans after COVID-19 are supposed to wear a mask. You wear a mask, right? Face mask. If you wear a face mask, your algorithm cannot identify who you are. Agree? Your algorithm cannot identify who you are. But then look at this. It's like this. There is a mask and you don't know what's there on the other side, who this person is, for example. But then using your image processing, if you can get to the depth of it, you'll exactly come to know on what is there on the other side. These are there on the other side. So that means even if someone is going to wear mask, I'm going to run an algorithm which is going to just peel off this mask and determine who that person is. So even if you enter with a mask, algorithm should be able to identify, right? It should be able to identify, and that is exactly what we are trying to do in this space. So let me open the eye detection algorithm. First, it will detect the face, and within the face you have eye, so it is going to detect the eye. And of course, there is nose, mouth, everything, and we have many other things, but I'll restrict and confine to this. I'm explaining about the applications, friends. I'll not be able to explain the code because this needs good amount of Python knowledge. So look at that. Even with my spectacles on, it is able to identify who I am. Like that. Only this facial recognition algorithm doesn't work the way I want it to work. Only this part. I mean, it doesn't go away when I press escape key, unfortunately. Okay, and there are many other things that you can do, such as seam carving. Okay, let me help you understand about seam carving also. This is another algorithm that we have, and then you have video part, video. Okay, let me get into the video part because we have limited time. Is it only images that I can load into OpenCV? No. If you say import CV2, you are importing computer vision. And then you can say CV2.image, sorry, video capture. And then you can provide your video file. And then you can actually stream that. So let me run this. There's a video of a birds flying. Kind of, I can play it once again. It's a small video. So the point that I'm trying to drive is it is not just the images that you can load and analyze. You can also load videos and then analyze the videos also. And there are a lot of such applications that we have built in the past. Optical dense. Okay, fine. Yeah, look at that. So what this is going to track is these vehicles which are moving. It's going to track and count how many vehicles are there. And even if it's a night vision, it will identify. It can also identify the density or on whether you have too many vehicles coming or too less vehicles. Is there going to be a traffic jam or no traffic jam? Which direction are the vehicles going in? All these kind of analysis you can do. And as part of our artificial intelligence training, we also help train people on how to build an autonomous vehicle. What algorithms are going into that? There was a question by one of our participants now in this class only on radar. Do you have any radar related data? RADAR. We do have, but yep, that's part of our AI training. And then in that we explain about how driverless vehicles are built, what kind of algorithms are used, so on and so forth. Okay, and one more thing is on next week on first, second, and third, that is Monday, Tuesday, and Wednesday, we are conducting an exclusive series on manufacturing and automotive analytics. Okay, manufacturing and automotive analytics. Here, people from MTech background, or sorry, mechanical background, electrical background, because we also have a lot of use cases in terms of electrical engineering, and then electronics background would come. Mechanical, electrical, and electronics background people would come, and you all are invited. If you want to know more, you need to drop an email on uh, inquiry at the rate 360digitmg.com, and then you'll be notified more. Yeah, inquiry at 360digitmg.com. Okay, so enough of the video. Let me skip that. Then there is also something called as single shot. Right, there is something called as single short object detection model. So if I give you this traffic video, and if you have airplanes or bicycle or bird or boat or bottle, any of these, right, within that, it will quickly identify. That's the advantage. It's going to quickly identify all of these. So let me run this and then show it to you guys. Look at the power of computer CV, not just neural network. This is also amazing. Look at that. It is putting a bounding box around the vehicle which is passing, and then it's also giving a probability value. If the vehicle is far away, it starts off with a lower probability, and then as and how the vehicle comes closer, it increases the probability that that's a car or that's a bike, etc. If it's at a far off location, that's how it works. Okay, and then why am I waiting? Because there will be a bike also which will come after a while. I just want to show you that's going to put a bounding box here. The bike guy is coming. As and how that bike comes closer, it will determine that it's a bike. Yeah, look at that. It's saying that it's a motorbike with certain probability, this guy. So it in that way identifies all these vehicles. You can automatically count the number of vehicles which cross a specific traffic signal. Okay, that's the stuff. Okay, okay, sure. Python. We are planning one, Bhaskar, right from scratch. Yeah, basics. The images overlap. How will we? No, you cannot discriminate, Gyaneshwar. It only does so much. Right? That's called as occlusion. If you have any occlusion problem, you cannot quite solve that. Right? One behind another, hiding behind another. So those kind of things we cannot actually solve. And any MATLAB session? No, MATLAB is something that I worked long back, Sri Lakshmi. But if you ask me on a serious note, that would take you in a wrong direction. Python and R. These are the new tools you have to explore. MATLAB is not that mature now on the latest of the algorithms. Okay, and then you also have scene segmentation, meaning given your image, you can also segment various things. Like if it's humans, all the humans will be given a single color. If it's, say, objects, all the objects will be given a different color. What happened? Yep, look at that. So if you look at this carefully, and it has done a pretty good job here. Okay, so it says that here we have a human. That human is identified here. And there is a human here. She is also identified using a different color. This notice board and this vehicle are also identified using a different color. Rest all it's saying there is nothing very important in the image, right? Of course, it won't be 100% accurate, and hence it could not identify this portion. But then whatever best accuracy we can obtain is something that is available here. Of course, you can retrain this model. You can do certain other changes. You can increase the accuracy of the model. All that is something which is possible. And then let me also show you face detection which will also capture your emotion. These are all the projects, people, we have already done that for various customers in the past. And oh, let me run this. Okay, hopefully. Come here only. Okay, let's see. Error. No. Okay. So what is it doing basically if you look at it? It's putting a bounding box around the face and it's giving the emotion that this person is neutral, neither sad nor happy. This person is neutral basically. And then one last thing before we wind up for the day, the same algorithm, but then this does an amazing job in terms of detecting the humans in an image. How many people entered your shopping mall? Today, all that is pretty easy, right? One second. Here, here, okay. Let me see if I can install that. I think that was already there. Yeah. Okay, let me run this. Human detection algorithm. What? Yeah, here it is. So what it does is, even from the back, it can just identify whether you're a person or a person or not, and 98%, 97, 99, 100% accuracy. Amazing, right? And it's quite cluttered. I mean, it's not that people are walking with a hands arms distance, right? They're very close, but still it could identify that. But if there is someone in front of this person hidden, then it cannot identify it. Even as a human, you cannot identify. And then remember that these are all algorithms which are being built to replace humans in majority of the cases. If humans cannot do something, then of course your algorithms also might not be able to do better. Okay. So these are a few things that we covered as part of computer vision, etc. Tomorrow you will have a brief about convolution neural network, and with that we'll wind up. So please attend tomorrow without fail. And I've also seen that I've seen a few of your comments. This is just a request on relooking at your feedback. Do you have any comments on this? Hey, sorry. Are you all able to see my screen? I'm sorry, I got disconnected. Okay, fine. Do we have Gandham Manasa in this session? And what happened? And then Manasa 5, sorry, Sasita 503. Do we have? Please let me know if you're there. Oh, we will place Faraha Sheikh. We are going to place these videos on our learning man so on YouTube channel. So do not worry. Yeah, yeah, we'll give you the video. No doubt about that. We will share with you the videos also. Yeah, Sasita, you're there, right? So you have asked for radar data, right? Yep. So you can just subscribe to our YouTube channel and you'd get the videos. Okay, you can just subscribe and you'll get the videos. All right. So Sasita, maybe you might want to leave your phone number. We'll just call you because we need to discuss about that feedback that you've left on the Google review. And we have Gandham Manasa? Okay. Um, we will notify you, Jyoti. We will notify each one of you on when we are going to have a session. We are going to have Python programming session on, let me tell you the dates right away, on 1, 2, 3. So it'll be on 10th, 11th, and 12th of June. Free Python training. All right, friends, then thank you so much. Okay, please. Uh, so what we will do is, Sasita, on first, second, and third, we have this manufacturing and automotive analytics, right? So what we shall do is, you can just drop an email, and then we will share with you the link. You can join on this link. Uh, just drop an email if you are interested. Inquiry at 360digitmg.com. Inquiry at 360digitmg.com. Yeah, and then we will help you further. You just drop a note there. Please, yep, Python programming, please join. It will be right from basics. Okay. All right. Enoch, anything from your side?
Nothing, Bernie.
Nothing.
All good.
All good. All right. Okay, friends. Thank you so much. We will connect tomorrow. Tomorrow, one of my colleague will connect, and then they'll walk you through convolution neural network. Yeah. Thank you all, and have a good day. Thank you. Bye. So please drop a note to inquiry at 360digitmg.com. Thank you so much.